Hello, purpose of this video is to examine one of the functions we were asked to study for homework. The goal or objective in homework was to take this equation in standard form and represent it in vertex form. I figure I should take this all the way through just to go through the full analysis procedure to find out what we can learn about all of the solutions to this equation. And so the goal here is really just to practice using all the different tools that we have and analyzing, that is, taking something complex and making it simple by understanding it the smallest parts. So to begin with, I start with a mental sketch. The idea behind the mental sketch is I should figure out where are all of the solutions to this equation going to lie. So I can see that the y-intercept is going to be below the x-axis, the parabola is going to open up. Now I can predict the nature of the axis of symmetry and the x-intercepts and match them up against my predicted outcomes. So we don't have to say anything about the sketch, but we should refer to it as we do all the work that we do. For example, starting with the process of completing the square to get this into vertex form, where I kick out the -3 and I factor out the coefficient on x squared from the first two terms. 10/3 is going to be the number that I use to determine how to make a perfect square. Half of 10/3 is 5/3. Squared gives us 25/9. Now remember, 25/9 has not actually been added to the right side of this function. It's actually 3 times 25/9 for a net effect of 25/3. So it is 25/3 that I reduce by to make the balance in this expression on the right-hand side of the equation. This portion was designed to be a perfect square, so I factor it accordingly, and I collect like terms on the outside. And with this form and the given form, I'm able to ascertain all of the following. I can state the y-intercept very clearly from the beginning form. Axis of symmetry, vertex, I can get from the vertex form. Bonus point, I just add the axis of symmetry or double the axis of symmetry and use the y-intercept. And now this wasn't requested, but you can learn your algebra by finding the x-intercepts, letting y equals 0, and solving this equation. And remember, to solve equations, we go backwards from the order of operations. So if I evaluated this function for x equals 3, I would take 3, then add 1 2/3, square, triple, and then subtract 34/3. So I'm going to do everything there in reverse, starting from the inverse of subtract 34/3. Straightforward. Now before I take the square root, this is not a perfect square, so I'm going to get rid of it. I'm going to divide both sides by 3. In other words, multiply both sides by 1/3. 34/9 is the end result. Now I'm going to invert the square, which is the square root. Don't forget the absolute value, which breaks up into 2 separate equations, one with the opposite and one with leave it alone. And when I solve each, I get this very ugly number. But one thing I can do is look at 34 as approximately 36. Oh, the video rages on. I can look at 34 as 36. 36 square rooted is 6. 6 over 3 is 2. So I'm really going to add or subtract a number slightly smaller than 2. So if we take -1 2/3, an additional 2-ish more, that should be -3.6 something. I put 9 something, but I wasn't really thinking. Here, this would be -1 2/3, and then we're going to add about 2, so it should be around 30% or so. And so that's that guess. And you put all the pieces together. First, the vertex, the axis of symmetry. Notice how I labeled them. I've got my y-intercept and my bonus point. I label those. Draw the parabola to the best of my ability, and then I verify that the x-intercepts match my predictions, which they do. So I label those as well, and I can move on with confidence. Since I have access to the technology, I'm going to put the equation into Desmos, see what I get, and notice all of those different attributes that we found. The y-intercept matches the axis of symmetry, x equals 1 2/3, negative, that matches, even though I wrote that down wrong. I should go fix that, huh? And then, yeah, let me just put that there. And continuing on, oops. Everything basically as predicted turns out to match what the computer says. So I'm just putting this up here to remind everybody that you should always follow through and make sure your work is done correctly. So in a nutshell, that's quadratic analysis. Once we get our function into vertex form, all we need to do is crunch the data and we can put together a really good setup. Sorry, I'm sort of editing as I talk, just to make sure the record is straight on this. It should be negative 1 2/3. Oh, that didn't work well. Anyway, you get the idea. Have a nice day.